Anyway, those of you who are present, please give us an idea what you are doing, where you are. If you are joining via WebEx, then I would ask you to switch on your video and give us some idea what you have been doing. Shall we go by the names? Yeah. I see Shubhankar Das. Yes, good to see you. So can you... No, your audio is muted.
Is Shubhankar in VCC? It looks like.
You are in SINP, right?
Oh, SINP, okay.
Your audio has to be...
No, you're still muted. The mute is at the bottom of the screen, wherever you...
Sir, can you see me and hear me?
Yes. Now we can hear you. Yes.
So both of you are sitting side by side. Okay.
Yes,
fine.
yes, sir.
Not an issue. Yes.
Okay. So who goes first? Shubhankar, you want to tell us what you have been doing? If you have faced any problems, any particular questions you have?
Sir, actually, I need some previous videos. Actually, so I have mailed Shubhankar sir and you, I think.
Yeah,
Actually,
Shubhankar sent a mail on Friday.
yes, Shulogna and I also. So
Yes.
actually, right now I am writing my thesis also and about to submit. So I'm little bit slow with this course, and parallelly I'm doing that. So this is my issue. But obviously, after 1 week, I will almost free. Then I will, forcefully I will do this course actually. So. So this is my issue, and
Shubhankar, you want to add something?
A good choice of words, maybe. You should not be forcefully into this course.
no.
Yeah. No. Sorry. Just pulling. Yeah. Okay. So what we wanted is basically it's okay to grab. So grabbing everything together might be a little bit harder. So that's why we requested if you can spend some time, because if you go ahead with everything, no. So eventually, what we will do is, okay, I do not know this. Let me ask ChatGPT. So what will happen is that understanding the flow, that it takes time, some rigor will get missed.
Yes.
So I understand other things are in priority, but still the request is again to carve out that 30 minutes of the day for this course, including excluding the course talking hours, because otherwise grabbing everything is a little bit difficult. It doesn't matter who you are. So my suggestion would be you please allocate that time. Otherwise, it will just be very difficult. At the end, you will say you have understood and you've done everything, and then after 30 minutes, nothing is there. So, yeah, my suggestion would still be carve out that 30 or 30, 40, 1 hour every day. Give it to this course.
Yes.
Okay.
Thank you.
No. Thank you is not required. You work on the course. Yes. Yeah.
Shulagna may have some questions. Do you have any questions, Shulagna?
Hello, sir. Can you hear me?
Yes, we can hear you.
Yes, sir.
Go ahead.
Sir, actually, I could not hear the previous conversation properly. So,
No, there was nothing technical about it.
okay.
Shubhankar was just saying he's tied up with writing his thesis. but you. So what we would like to hear from you is how far you have progressed. If you have any specific questions or some things you found difficult, anything you want to tell us or ask.
Actually, right now I am sitting beside Shubhankar Da. So we were discussing about how do we progress in building the data set, because we were supposed to submit at least up to that within 15th October. But during this puja and our other lab work, we could not progress much. So right now we have started, but it is actually being somewhat difficult to proceed by just seeing the lecture notes. So it will be helpful if we can get those lecture slides. Sorry, the lecture videos. So
No, that we'll see. We may make those available for some time. But can you remind me precisely what you are doing?
so we were trying to predict the band gap of different transition metal doped semiconductors.
Mhm. And do you, so that is your idea, but have you identified a data set? Do you know that such a data set at all exists?
Yes, sir. I did some search, and there are some data sets. There have been previous research done on this aspect. So,
Yes, research has been done. What I'm asking is, see, research having been done and having a sizable data set which you can use for model training are slightly different things. The data may be scattered in the literature. Uh,
okay.
in that case, it is not easy or practical for you to gather everything, create a data set, and then you at least want to have few thousand materials. And for doped systems, I don't know how many would be good. But just saying that, because this is just an exercise in a course, assuming that we don't want great accuracy or anything, you just want to show that things work. You still would like to have a few thousand materials, a few thousand examples in your training set. Do you Are you sure? Have you searched the literature, and are you sure that that many experiment or independent experimental results exist, or experimental or theoretical, whatever?
Sir, sir, I do not know that there is any such proper data sets, but there have been experiments and theoretical studies, so that data may be scattered, but there are data.
So that is precisely what I'm coming to. If the data
Mm.
are scattered, then gathering those and creating a data set is not a trivial job. In fact, that is one of the areas of research in this field where people try to parse the literature using some language models to create data sets. Okay, so manually doing it is, I don't think it is practical within, in any case, and particularly within the finite time of a course. You have only a couple of months to go, 1.5 months to go, something like that. Shubhankar, you want to add anything?
No, that is like correctly pointed out. So if you, matlab, it's not expected that you do state of the art. That we want to clarify. But even to practice also, you still need some data set that will give you some level of validation if your thing has worked or not. That should be in order of at least thousands. matlab. Otherwise, any 100 is just a
Exactly.
fluke. Even if it comes like a good accuracy or bad accuracy, you will never know what has exactly happened. So my suggestion would be like starting immediately to at least gather. And because I don't know if it happens in material science, processing can confirm. Like even if the data has been gathered, it can vary from system to system where they have gathered and how they have gathered. So if that is a variation that is included, I think Professor Sen talked about it already in his slides. multiple ways to gather data that makes it a completely different data altogether. So basically, you will eventually have, let's say,
Yes.
collected 100 out of some place and 100 out of another. You cannot merge them directly. So I think he specifically spent
No.
one day, complete day probably for this itself. So which is important.
Yeah.
So please start gathering immediately. And what we'd love is if you could also like ask questions. Okay, these are the things that we have gathered. What to do the next step? Is it okay to combine? Is it okay to merge? Like these questions should come from your end. Then what model to start with? What model not to start with? Or maybe before model, what could we do? So I think we are covering all this and step by step on also, but you can go with us in that journey rather than, eventually I will find a data set where I can run a model and get an answer. That will be a very difficult task, given you have chosen a very topic where the existing data set is not available in large number. So quickly, well, at least one or two you get and you keep asking, like you open a chain with us, like you keep processing us and Shubhankar and you both, all of them, and you follow through that chain. You keep on asking questions in that chain so that we help and we also understand. If that is a nice problem, maybe we can take it up also. Yeah, fine.
Yes. So, in fact, I would like to tell you, a few of you who are present here, is that at least those of you who are crediting the course, or those of you who are putting in significant time and trying to learn things, is that you write to us. You ask during the class, also, you write to us if you have specific questions, problems. It's not that only when we ask you have to respond. This is exactly what Shubhankar is saying. And coming to the data set, I would recommend that you try to simplify the problem a bit rather than going for band gaps of transition metal doped semiconductors or whatever you said. You just maybe you could play with the models and the features. So you have several possible features that we have talked about, and then we have talked about a few models. Now you can try to do a test that, and for this you will have a reasonable size data set from say materials project. That's not a problem. You have plenty of data there, so data set size will not be a problem, and they are consistent in the sense that they have been calculated with fixed accuracy with a definite method, so they are consistent. And then you can try to see which combination of maybe features and model gives you the best results.
Okay, sir. Then we can think about changing the problem statement
Mm.
a bit so that it generalize the problem, and then maybe we can find enough ready-made data in the materials project.
Yes, you will find data in a materials project, definitely.
Yeah, and the problem statement change should not be like the primary goal. You first make sure that there is an availability. Like you data set,
Okay,
you
sir.
try and everything else. Like
Okay, sir.
Yes,
statement
yes.
title change should not be your priority. That can come later. We'll fix that later at the end when you submit a report. But first you try,
Mhm.
get the data set, try all this, like finding features and all this. Then you pick up, okay, maybe this is interesting. We want to pick up this.
Okay, sir. Okay, sir. We will do that.
Yeah, I just suggested one possibility which is practical. I know the data set exists. You can think of other possibilities, but make sure that you have a set of consistent data. That's what I'm saying.
Okay, sir.
All right. Any other problem or questions you have? Any? Yeah,
Um, no, sir. Not now. If anything comes in mind, we will write to you.
sure.
And still the request goes, both of you, like please keep doing something every day, this or that, and ending with a failure is also okay. Like, okay, this error came up, you can stop there and go pick up the next day. But the problem is everything, if you do it together, no, one simple dimension error, if it comes, you'll be like, okay, nahi, project is wrong. It should not be that way. Okay, so every day some try has to be there. better would be even like even if materials data does not coming to you directly, you can try with simple data sets also, just to give you a flavor of what is like features, how do we play with it. Let's say the features are zero, how do I remove it? Or the features are empty, what do I do with it? A model runs, what, how do I basically train a random forest, let's say. Is it working with plain data set which I understand very easily? Then only I go to materials data set, which will basically improve your confidence, nothing else. Basically, you will not keep on asking 10 questions at the same time. Rather, you will be okay, feature ka I know, model ka I know, data set preparation I know. Then, okay, now only question will remain on materials part. So that's why, like every day, there has to be something. So if that has not been done, okay, from lecture one, whatever we have struggled, you start every day doing now, at least. Yeah.
Yes, sir.
Okay. Okay.
So I see two others in this session, Rahul and Joita. Joita, would you like to tell us what exactly you are doing, and if you have any questions or facing any problems? Is she there?
Yeah, he or she replied, I think, at 4:45 p.m. there was a chat message. So I think,
Yes, I see
yeah.
that. Anyway, is Rahul, are you there? No, Rahul, you are not audible. No, no. You can type in if you want to. Both Rahul and Joita. But how? Rahul, you are not audible. Do you think you can fix your audio?
Yes,
Yes.
yes.
Sure, sure, sure.
Enjoy the same also. If you can join from another device, that would be nice.
Joita, if you want, you can type in. First is what exactly you are doing uh, right now. What kind of problems or what kind of exercises you are doing. Okay, bond order values for molecules, and I don't know much about molecules, but do you have data set? Do you have a data set? Okay, but again, as we said earlier, you need several thousand of these. So, do you think it is feasible that you can calculate bond orders for several thousand molecules and then use that to train your model?
100 means just 100 rows. Will that will be very, very tricky.
Yes, 100 seems looks too small. See, as far as I know, I do not have any first-hand knowledge about molecular data sets, but from what I understand, there are many large molecular and 3, 4 bonds on an average, but still it's in the order of 100, still small. So what I was asking you, Joita, is that from what I understand, there are many molecular data sets available. I do not know if these are all free, but if there are some easily accessible free data sets, can you use those to predict, maybe not bond order, but something else, some other property of the molecule? Is that possible? In that case, you will have larger data sets. Sure, you can try to predict the IP minus EA or the homo-lumo gap or whatever. Just see what models, what features perform how. That can be an exercise. Yeah, you see what data you have, but at least a few thousand is, I think, reasonable, even for a class exercise.
Yeah, because in a few hundred you might get like bad results, and that will break your confidence in ML. But like as uh, but like starting, we told like everything is on the game of data. So the more you have is better. Or either if you're saying you have a homegrown code, if you can generate for more molecules, that would be nice also.
Yeah,
That
that is
so,
that would be.
So that would be also nice, but at least you have in some, yeah, order of thousands, maybe few thousands, so that at least it gives you some confidence.
Hmm. Okay, anything else you wish to add or ask, Joita?
And another thing is like even if you know some properties of the dataset already, you can randomly create that just to test your rest of the pipeline. I'm not saying this has to be absolutely exact, but by the time you are generating this dataset or finding, you can still play with the like sample dataset you can create randomly, and then you can test rest of the pipeline. So that, like for example, given an input, how do I make sure entire machine learning model runs, trains, validates, and then how do I generate graphs? So when you just get the data, you just plug in that data into your pipeline and everything is done, right? So that you don't have to look for both of them at the same time. And this is like an industry practice. It's not something that you would be doing new, but this is what everybody else also follows. In case we don't have the data set right now immediately, we generate the pipeline at least. Okay, so given a data set, I know it will come in this format. What can I do? So you could have that pipeline also ready. So that applies to same with Sulagna and Shubhankar also. So this should be, it looks very similar, but I think this can be two independent thoughts also. By the time you're gathering data set, you can build your pipeline. And while you're just gathering data set, you can think in more terms of features and everything. Yeah. Fine. And lecture number 23.
Section number 23.
Okay, we will make them. It's on neural networks. Yeah.
So we'll make these lectures available for maybe all of them for a window of time.
Yes, yes.
All right. So shall we ask Rahul again? Rahul, is your audio working? Or if not, you can type in. Shubhankar, she wants me to repeat.
Repeat on which one, Jyota? Sorry.
I
Uh,
think this preparing the building the pipeline. I think
Oh
that.
yeah, okay, okay. So yeah, Jyota. So if that is okay, so first of all, your question on lecture number 23, we will open up all the lectures available for a period of time. Give us some time to coordinate with HBNI for this. The second question on like by the time you are looking at the dataset, finding a new dataset, or preparing even more dataset for the molecules, you can still prepare the pipeline. Let's say you assume that the dataset is available, you can bring like create a random dataset. It's better if you know some properties so that you can imbibe some properties in that random data, and then you can build the rest of the pipeline. Like which, for example, which features to select. Then machine learning models should look at which features. Then this is the output that will give. And once the output is done, how do you plot graphs? And also that is not that easy. Also, let's say you have the machine learning model, like then which loss functions to choose, what should be the hyperparameters should I look at, what all models will perform nicely. So all these questions is something that you can still answer, because from domain point of view, understand this is given and this is what I want to predict. So by the time your data set is getting built or collected, these are the questions you could basically get it done, right? So you don't have to wait till the data set, okay, no, data set is not here, I cannot do anything. So this could be two parallel things. You will still have to answer these questions when you have both the data set and both the data set and the pipeline. You will still have to go through the entire step again, but that will make things way easier, or how do I say, life will be a lot easier then. Otherwise, there will be just too many things doing at the end. Hmm. I hope that helps.
Good evening, sir. Am I audible now?
Yes,
Yes.
Rahul. Yeah.
Yes. So as we have presented in the YouTube video, that we are using different regression models for lattice thermal conductivity prediction at particularly 300 Kelvin. So we are using Airflow database to collect the data. So we have already downloaded and curated the available data that is available on Airflow, and we have performed this featureization part that contains compositional average quantities, stoichiometric features, chemical features, and configurational features using sign matrix and atom-centered symmetry functions. And we have also performed the feature selection method using recursive feature elimination using the random forest with its default settings, default parameters. And we are now evaluating defined models. No, so currently we are performing the k nearest neighbor. So that code is currently running in our cluster. So yeah.
Okay, so is that the problem? So that is your problem statement, is it? Predicting thermal
Yeah,
conductivity?
yeah, that is thermal conductivity at 300 Kelvin.
Okay. But the data you have is not at 300 Kelvin, is it?
It has the temperature ranges between 0 Kelvin to I think 2000 Kelvin. So we are using that particularly 300 Kelvin because that is the most usable temperature range.
Uh, no, no, that is all right. What I'm asking is a rather materials question or question about the data set rather than specific machine learning method or model. Is that as far as I know, Airflow data sets are created by DFT.
Yes.
Do they have experiment? So how do they incorporate the temperature information in that data set? That's what I'm asking.
So they have the values are calculated using Phono 3Pi with PV functional. So in Phono 3Pi, you can incorporate the temperature ranges to calculate the thermal conductivity.
Okay. So through phonons, the temperature is built in, you are saying.
Yes, yes, yes.
All right. Uh, yeah, apart from that, any questions you have? Anything that you would like
Not
to
until now. So
ask?
it is actually going as we have planned. So
Okay.
Yeah, so Rahul, so again, like this is to all the teams that you have, you please start a chain with us, email chain, where you can basically, even if you have got something, you please report it there. For example, we tried this model, this is what happened, this is not what happened, these the features got highlighted or not highlighted. If you can start a chain and keep us updated, that will be really nice. Then we would know progress. We would also ask you more questions. You can ask us questions in that particular email chain. So I would love if all of you can start a chain regarding your project in the like at least email chain with us. That will be nice.
yeah, sure, sir.
Yeah.
Okay. And a general comment I would like to make is that please keep in mind that any machine learning exercise is it's not a black box. You need data, you need quality data to get meaningful answers. So therefore, and as Shivankar just said, I mean, the more good data you have, the better. And along with data, you need to employ your domain knowledge. Whatever problem you are working, knowledge of that domain has to come in at some level, somewhere. Otherwise, I mean, it just cannot be a statistical exercise. So these are very general comments that I would like to make. Okay, anything else anyone would like to ask or want us to discuss? See, as a guide, I think I wrote in my email that Shubhankar also asked you to, left many things for you to work out, suggested some even today. And in my slides also, I have left many things as marked as tasks. So those are things you can try to do. Those are small exercises based on whatever I have discussed in my lectures. And that will make you more familiar with how to use different databases, different libraries like Describe, and in the next lecture we'll go to using scikit-learn for doing materials property predictions. So those will just give you more exercise in these things. All right. So if there are no further questions, we can wind up in a couple of minutes. And next lecture, I'll teach. Basically, we'll go over to materials property predictions using scikit-learn. Okay. So shall we close?
Okay. Yeah, every day, please, 30-40 minutes. Yeah. Thanks all. Yeah. Bye. Bye.
Yeah. All right. So I think we'll close here.